Okay, so for people who are watching this live stream, this is one of an infinite series of meetings adding polish to the Wolfram language with lots of looking at specific functions that might be incrementally put into the system. So let's get started. All right, Will. So for millions of years, we've had this function called bool that, wow, there are initialization cells in here. It's interesting. Okay. That does that. So the question is, do we want something that goes back from 1 and 0 and turns them into true and false? I think we imagined doing this right when we invented bool long, long ago. But for some reason, we never actually implemented it. I mean, we're going to call it inverse bool, basically. Anybody want to comment on that?
What would it do on other numbers?
That is a good question.
50 Shades of True.
No, I think the obvious thing to do is to do what it does. I mean, what does bool do if you give it something other than true and false? Okay, it just stays unevaluated in that case. I would think it would turn into true for any other number. Now, what should it do if you give it 1.7? What should you do if you give it machine 0?
Mm-hmm. I would say any kind of 0 is false, any other number is true.
I agree with you. And I would think that anything else remains unevaluated.
Right. Anything simple, yeah.
Maybe it could be extended to empty list goes to true. Empty association goes to true.
I'm sorry, to what? Which?
Inverse bool.
Yeah, of what?
Empty list.
Empty.
Yeah.
What would that do? I think that should go. I think it's got to be listable. That would have to go to null list.
Yeah.
So it would put only on numbers. Okay.
All right. Let's look at so the other case of this is the enum case, where you're basically taking an indicator function that is saying, you know, I don't know, this is a bad name for it, but something where you say 2, and then the enumeration is A, B, and C. I mean, this is kind of a stupid function because that is really, you know, that list sub 2, basically. Now, the only thing is, so that would give B. No, that's the inverse enum, I guess. Right, and so the other case is the enum analog, which would be something like B, comma, ABC. Am I making sense? And that would give 2.
And what's the relation with bool?
Well, it's the same idea. I mean, bool is going from the true-false, to an integer, right? This is going, I mean, arguably, you know, you could do something where by default, if you ask for something that isn't in the list, it would give 0. Right? I mean, the alternative way to do that, which might be a little bit weirder, perhaps a bad idea, is the second argument to bool.
But what confuses me is that bool acts on booleans. Why is enum an NRE version of that?
Well, I mean, the point would be that the default bool would be yeah.
So you're thinking of a member queue, or of generalizing bool to a characteristic function or something like that.
To which?
To a characteristic function, something that.
Yes, that's right. I mean, this is like characteristic function. I mean, this would be something like, you know, that would be what bool would be That will be the full form in this concept, where that says, here's the list of trues. This is the no, it's false. It's, you know, it should give 0. I don't think the champions of this particular thing are in this meeting. I mean, I think that the statement has come up a bunch of times in things like image processing, where you're saying, you know, given this list, I mean, clearly this is fairly easy to do with part.
Right. Sorry, I'm still thinking about inverse bool. What we proposed is basically possible 0q, which also has the question of what do we do with some sort of Trottian 0? That's very complicated and not obviously 0.
It's hopeless. I mean, you know, in other words, it's looking structurally, is the thing a number? No, okay, so the question then that will come up is, what about inverse bool of, you know, pi squared? Should it numericize it to determine the answer?
Well, I'm worried about those cases in which we have a complicated numeric expression, which is actually 0 if you apply a full simplify, but it will take some time to realize that.
No, I know. I'm saying punt in those cases. I'm saying if it's not an explicit structural number, don't try. Just return unevaluated. I mean, let me point out, if you did return unevaluated and then you hit it with n, or full simplify or whatever, that will resolve it.
Right.
Okay, so look, none of the champions of this enum thing are here. So I think we should not figure out what to do with enum right now, but the inverse bool thing seems straightforward. We had planned to do it when we introduced bool originally. Let me just, I'm just curious. I'm just going to search my archive for the inverse bool business, just because I seem to remember that that was a discussion. Let's just see whether we had anything else to say about it. See how many years ago this was happening. Well, inverse bool came up in 1997. To-do list. This was our, just to entertain ourselves, I suppose, this was our to-do list in 1997. Which of these have we now done? We have done list convolve. We've done that. Yeah, interesting. We've got divides Q and we've got substring Q. So the only one from 1997 that we don't have is inverse bool. Let me just see whether there's any further discussion that was of interest subsequent to that. We seem to have had a whole bunch of discussion in, when did bool, wait a minute, when did bool come in? Yeah, right. So this is further discussion 1998 of inverse bool. And it seems like 2008 we had a whole bunch of discussion. A short name for the inverse of bool. Okay, so we had a discussion about this. Okay, that's amusing. We had a discussion here in which just to show you this one, in which the possible 0q, this exact same discussion came up.
I see.
It would have been worse if it was you who brought it up as opposed to Brett and Bhuvanesh. Okay, well, look, it seems like inverse bool is a perfectly reasonable thing to have. We just didn't have it before because we never got around to it. I think now we've got reason to have it. We were asking, extensively here for a short name, for another possible name. Oh, for goodness sake. That's somebody had suggested Spock as a name for inverse bool. Great. Very funny.
Danny?
You mean who suggested that?
Yeah, it seems like a Danny suggestion.
Oh, that's funny.
Wasn't me.
It's I think it was a joke. It might have even been initiated by me. It looks like my bad sense of humor here. Okay, anyway, there were no serious other suggestions. Oh, ideas were unbool and debool. This is oh yeah, these are very non-serious suggestions. I mean, these were unbool, debool, Aristotle, not a serious suggestion. Logical. Could we get whoever's got background noise? Could you put yourself on mute? I think inverse bool is the least crazy of these. Comments from other people?
I was trying to find something related to 0, because what we are doing here is some sort of, it's not explicit 0q, because it's not a q function. But this is a function that targets 0 explicitly.
Well, you can think of it that way. I mean, I see what you're saying. This is a function. I mean, the question is, should you think of it as, asking a question about an integer, or should you think of it as essentially a type conversion? Okay, someone is suggesting on, Sander is suggesting eloob, which is funny but not useful for inverse bool. Okay. Gosh, can we see any other better name? Debool. I think debool is much more obscure even than inverse bool. Any other thoughts here?
Bool.
That's not crazy. That's not crazy. Might be better than inverse bool. Inverse bool suggests something mathematical and one-to-one and so on.
This is almost from Boolean, which is precisely the opposite.
Look, the whole point is George Bool's big contribution was to say that what had been called true and false could be viewed as 0 and 1.
Right.
And what we're doing here is we're saying, okay, answer the question. I mean, maybe this should have something more like.
How about the Boolean? It's really more to true false.
No, that's confusing things even more, because we're saying bool, the contribution of, George Bool, his contribution was, Aristotle and friends had true and false. Bool said, no, you can view those as 1 and 0, right? Now, Boolean in programming languages has come to mean something that has these two possible values, which represent true and false, but in programming languages end up being often written as 0 and 1. Does that make sense? So it's very confused there. So I think Boolean is a hopeless way to go.
Yes, it says that this will be a function that returns true or false, but it's not a q function. So I'm trying to align it with some other function that has that property.
Right, but we have to have a way of thinking about we've got to have a way of thinking about this in terms of, look, I mean, clearly this thing is basically non-zero Q. Yes, in fact, someone pointed out on the live stream, it's basically just the function positive. That's true. I mean, this is one of these cases where, well, it's sort of true, except that in this particular case, it's anything other than zero. What is the relationship between this and Kronecker delta? That I guess Kronecker delta has two arguments, right? Yeah.
I think it can have any number.
Okay, fair enough. You mean including one?
Yes.
But then I bet it's always going to give one. No? What does it do here?
I think it's the other way. If you put 0, it gives
I
1.
see. Okay, fair enough. Okay, so this is closer to true, false. Okay, the question is, you're seeing a piece of code, and that piece of code says, list here, and it says something like, let's say it says pick, ABC, and then you see a piece of code that says something like that.
Mm-hmm.
I have to say, I think that true, false is less obscure than saying inverse bool or from bool.
I know it's a bit long, but how about logical value?
I think that, okay. The thing is that it's mapping from this hack, which is the Boolean hack. I mean, that's what it really is. No, it isn't even integer, number to logic. I mean, this might suggest that it is a structural true, false thing as opposed to a computational true, false thing. Logical value doesn't that sound a bit too general?
I agree. And I also agree on insisting not having this function very related to the maths, because the problem of finding whether something is 0 or no is very hard.
Right.
Well, it's allowed to come back unevaluated, I would hope.
Sure. Which is a bad thing. True, false doesn't suggest that it could come back unevaluated.
Right.
I'm not sure because we don't have a Q. So it's the Q what tells that our functions return true or false.
Sure.
I had thought of truth value. I just kind of didn't like it because there's no false in the name.
Truth value. Okay, so what would the definition of truth value is?
It's okay. I'm not against it.
Well, does it mean the right thing? What is a truth value? Does a truth value, is a truth value something that one can reasonably say is let's look at it.
It has the same problem as logical value, which is that it sort of implies you're working in something like.
Yeah, I mean, in a typical version of this, like our friendly Wikipedia, blows itself up on line 1 on this issue.
Right.
What it says is, with truth values are 1 or t. So that's already blown up the idea that truth value means. Unfortunately, the word value is already, a problem there. Of course, this might also be the reason that we didn't do this before is because we weren't sure about the name. Yeah, well, the Sander on the live stream is saying bool would have been nice if the other was called from bool, but the whole point is that we're using the fact that the we're using this piece of history that maybe nobody knows about what bool actually did. I have to say the one that I'm least unhappy about will be true, false.
It has the advantage of being very clear.
Yeah.
In terms of what it does.
And I'm not sure that it is in any way, I mean, what we could do is we could say true, false, and then we could say that its second argument, if it has a second argument, would give potentially the list of trues. No, I don't know if that's the right thing to do. I mean, something would give the mapping, but the problem is the mapping is a zero origin mapping with a zero there, which is kind of a mess for us. I think we should go ahead and implement this under the name true, false. It's a little weird though, because bool is the inverse of true, false, which is kind of weird. All right, what do we have as the top candidates? We have from bool, which has the advantage that it goes nicely with bool. Okay, so let's say you see in your code, well, there, I wrote it out. Pick ABC from bool. It's a little weird because people think of Booleans. That's the problem with this sort of abuse of the term Boolean. Okay, what do people think here?
Of the things suggested, I prefer to true false so far, because it puts the emphasis on true false. It removes the emphasis from checking that something is zero. And,
okay, and you prefer it to from bool because you think people are already very confused about bool?
Yes, from bool, I think, yes, it seems to suggest that it takes a boolean. That's what the first thing I would read.
Yeah,
I'm with that.
Okay. Sandra's asking, is it from or to bool though? Well, the problem is, yeah, right. I mean, this is the confusion because bool, the George Boole in his book Laws of Thought in whatever 1830 something, 30 something, 40 something, anyway, around that time, his big point was you can do Aristotelian type logic using ones and zeros. That was the point. That was why. Now, that subsequently got utterly abused when people started talking about Booleans. All right, so listen, I think the tentative conclusion is true, false. Do we agree? Let's go ahead with that, and then we'll look at it again when we've got implementation and documentation. Fair?
Okay.
All right, let's go on to the next item.
Yeah, so this is something we have discussed before, and we have added here two sections from your notes from two files, carry 03 and carry 04, and then something I wrote long ago, before Christmas, when we were working on carry.
Okay.
This is just to recollect ideas and see whether you are still interested in.
Well, so the issue here is, can we make a pattern that represents an arbitrarily nested collection of functions? And the next question is, why do we care? I mean, we've been able to get away without this for 30 years. Why do we care? And I think the answer to that was there were things that were involved with Tony's work where it seemed to be important. And it is certainly something. So what, let's see, head depth.
So the idea here is when we were discussing carry, we thought that perhaps it was important to have a variety of functions supporting the multiple pair of brackets and nesting. So these are two different things, but both might be important.
Oh boy.
So this is more about multiple brackets rather than nesting, but the same problem appears.
Well, I don't think that head is the right brand, so to speak, for this. I mean, if there is a brand, it's going to be a curry type brand.
Yes, your notes are further down. We discussed things like subvalue, head, curry. The main conclusion we got last time was something called curry sequence.
Okay.
But I think this is more for multiple pairs of brackets rather than nested heads.
Okay, fine, but that's a different thing. So this case here is the curry sequence case,
right,
where that's a case where this thing can represent not just a single argument to f of x, but an arbitrary sequence of arguments to f of x. So in particular, it can match, what the heck? Well, that's not a complete thing there. This is saying, what is this saying? I don't understand this. Is that supposed to match? Okay, I see. So this matches that form there.
Mm-hmm.
So in other words, curry sequence is a matcher that doesn't care about the bracketing. It only cares about the sequence.
Right.
But how does it even know what the bracketing is?
Well, we would have to implement this. It's not easy to implement, but currently curry is able to ignore the brackets, the structure of brackets. Just counts. It just counts arguments.
Okay, so one of the issues that we don't have, one of the functions we don't have, is something that takes that and turns it into something like, I'm not sure what the right way of doing it is, but something like, no, actually that's wrong. I mean, but something maybe where there's sublists here, where it is, curry sequence to lists, so to speak.
Right.
We don't have any. What is the easiest way to do that?
I would use.
You can do it recursively with patterns. Go ahead. What?
I would use head, folding head, basically, or something like that.
Yeah, I mean, I keep on not thinking of this as a head, really. I mean, it is the case that this is a composite head, but I keep on thinking of it as going the other way and tacking on arguments in a curried form. Am I making sense? I mean, this in fact is a, so let's see. So, I mean, this operation, we don't have a good way to do this right now. On the other hand, we haven't exactly missed it in a very long time. What is, other than completeness, what is driving our desire to put this kind of thing in?
Nothing in particular. It just when we were working with curry, we thought that it might be interesting to have these things, but they are not very important. The same thing happens with the nesting of heads. It's something that might be useful in some cases, but there is no.
All right, let's not worry about this right now. Let's keep it on our list and let's not worry about it for right now.
Okay.
Might be a good topic for summer school. That's a good topic. If somebody can note that as a good topic for, we sometimes do some lectures on design. That might be a good topic for that.
Okay.
All right, let's move on. Apply thread. Okay, that is the famous thing that, what is this doing here? Is that the thing that combines association? No, that's a different thing. What is this?
So this apparently comes from another of your meetings.
This was from database integration meeting.
Yeah, I think the last line is the clearest one.
Yes. And do we like that name?
Well, to me, this is not our apply. It's more like construct. This is a threading. We can easily build this using map thread and construct.
Okay, so construct would do that. So what are you claiming? That this is some kind of thread construct thread?
Yes, or inner. For example, you can do inner, construct, and then two lists.
Yes.
And then, yes, you put there the two lists, and then you need a comma list.
Right. Right. What would be the convention here of whether this is, so in the case of thread, what that would be doing is it would be taking, if we said thread G of that, right, it does this. So in a sense, this is thread construct. Is that right?
Yes, I think so.
Is that obscure or is that a reasonable name? And by the way, given that name, right, then this should go, oh yeah, that's right. Those are two corresponding associations. Does thread work on associations?
I don't know.
That does not work.
Try comma G. I don't know. Sometimes with thread you have to specify which head. Or
No.
perhaps association, comma association.
Wait a minute. What is association thread?
But that's like map thread. It takes no, sorry.
No, you're right. That does a different thing. That's taking
A list of values and a list of key and create an association.
Okay, so the question is, why does thread not work with associations? Now, clearly, it's a little tricky because it's a question of reordering in the associations and so on. I think we should raise that question. Who would know about that? Would I know about that, perhaps?
Perhaps. I think this is a question for probably Konstantin.
Okay, fine. Let's ask him.
Mm-hmm.
I sort of vaguely remember that thread was on the list of functions to support association. Maybe it was simply down prioritized, or maybe there was some problem with it. Okay, so thread construct is a pretty weird name.
Yeah, in my opinion, it's very easy to construct it with inner, as we did, or with map thread. I'm not fully sure I see the need of this function.
Well, I think that there are a lot of cases in this database thing where, in this case, for example, I think the inner case is extremely obscure. You know, if I might say so, Sushma, I think process-wise, the fact that the people who initiate these functions aren't in this meeting is kind of unfortunate.
You suggested this function.
Well, okay, I'm in this meeting, so. But this came out of a discussion from
database integration meeting, yes.
Right. I think they had this function, but it was okay, I think we have to ask them again. I think it's particularly in this case here. Well, the question is there a 3-argument form of this function, for example? And by the way, I don't really support necessarily that it's thread because it doesn't really give, it's just giving the naked lists here. It's not actually giving, I mean, thread usually has, I mean, it's more like map thread, right? Because what it's doing is, it's just taking those lists. It's not taking G of those lists and then threading G through it.
Yes. I mean, the notation in map thread is much better than the notation in thread. I agree. If we can follow map thread, that would be better.
Yeah, but the problem is map thread. I understand, but map thread Okay.
We can do the same thing. Map thread construct, comma, the list of the two lists.
Yeah, I agree. That would work.
You need the list of the two lists.
Yeah, that works fine. Well, let's push this back to the database integration folk. And let's, two things here. We should make sure there are examples in construct and map thread that show that case there. And let's push back to the database folk and just say, use map thread construct.
Okay.
Yeah,
okay.
We have examples. And something nice here is that if you add a third list, then we can construct functions of multiple arguments very easily, which is nice.
Yes, that is nice. All right, fine. Okay, so for the time being, we don't need this function. Okay, should we go on?
Okay, yes. So this is the discussion of a function we have named in multiple ways. I'm still calling it nest thread, but yes, so the name is not clear because it's related to multiple other operations, a bit what we were just discussing.
Somebody is asking on the live stream, what is the inverse of construct? What is the inverse of construct?
Well,
the thing that takes that and turns it into the list fxy, for example.
Level with x goes to true.
Yeah.
Level
0, yes. 0
level
in
-1, I would say.
minus one. Yes. -1 in brace.
Yeah, but that's only going to work in this case. That's not going to do that in general. To do that in general, if I had x squared there, that's so the question is, how do you go from a head and arguments to a straight list?
Then it's level 1.
I see. So you're claiming is that it's just level of f of x, y, comma 1, comma heads to true.
Yeah.
Yeah, I think that's correct. All right, seems to be the answer. By the way, we might put that also in the construct documentation under properties and relations. We don't have it there.
Yeah. We will add it. Okay. So there is a discussion of the name, the syntaxes, some implementation, which you already executed, and examples to play with.
Okay. What is this again?
So this is the idea that we have an array and lists of keys, and we want to construct a nested association.
Oh, yeah, right. So this has gone through multiple names.
Exactly, yes. And I think the main thing here is that it depends where we want to use it. If this is only going to be related to rules and association, then probably we need a name which sounds very key association-like. And if it's generalized, as I did there, to a more powerful function that is able to work in other contexts, then I suggest some other name like this nest thread, which I'm not very happy with, but I'm not.
Nest thread sounds utterly obscure. What does it do again? Okay, so you're saying...
So it's the idea of the same operation here that you see there with those data sets, but generalizing rule and association to other heads. Like we generalize the f and g functions in other places, distribute, inner, etc.
Someone on the live stream suggests that this operation be called deconstruct. It's kind of interesting. I don't know if it's terribly useful, but it's kind of interesting. I mean, the problem is the fact that heads and their arguments are distinguished in some way. I mean, in the world of Lisp or something, that was not traditionally done, but in our it has turned out over the last 30 years to be very valuable to distinguish the head from arguments. This is kind of saying, that's a cute name though. It's a very cute name. Okay, to be saved away. That's. I don't think we need this right now. Okay, let's go back to what we're talking about here. So what you've implemented this under nest thread, is that right?
Yes.
Tell me what it does again.
So there are, if you run this key, the examples at the beginning of the section, I have an example of level 2 and an example of level 3.
Okay, but let me be not so obscure. Let's start off with level 1.
Okay, so it takes use the other function I also have there, which is called key distribute, which is simpler. Key distribute takes
okay.
Yeah. Key distribute takes the keys and the array.
Okay, so let me just type something in here. Key distribute takes keys, let's say ABC.
It's a list of lists, so it needs
why is it a list of lists?
It can be easily generalized. It doesn't work, but add 2 lists in the first one. Yeah.
Okay. So let me understand this. So those are keys. The first thing is, right, I remember this. Okay, so the first thing is a list of keys. And the second thing, so if I make this multidimensional by having a list of keys and then another list of keys there, why did it do that?
Now you need a 3x2 array in the second argument.
Okay, this is the thing that is essentially painting key labels over an object, right?
Yeah.
Yes, this is a useful thing. Why is that wrong? Because it's the other way around.
Oh my goodness! It's a 2x3 exactly. Yeah.
So let me understand that structurally. So if I take this, that's so kind of obscure, right? Because this case, okay, so this is the sort of the template for the structure. It's saying that at level 1, it's got 3 things which are going to be labeled like that. At level 2, it's got those things, right?
Yeah.
And so, okay, so that's what key distribute is doing. So what is your nest thread doing?
Yes, so now copy that input, change the name to nest thread, and now write F before as first argument and G as last argument.
Aye.
It's the same thing we do with inner
creature. Yeah,
exactly. Yeah.
And why do you think? I mean, in order to do that, what you just showed, do you think it's useful to generalize it that way?
Well, for example, sometimes you want rules, but you want lists, nested lists, not associations. And then you just would write G is list instead of association.
Yes. I mean, that's useful when, for example, there are repeated keys.
Right.
But wait a minute, in this case, you're giving the key pattern. And so unless you stick in a repeated key, you're not going to get a repeated key.
Exactly. But it may be that for some reason you need, I mean, because they are dates or something, and something happened twice in a day.
Why would they be dates? I don't understand that. Given that they're a nested structure like that.
Well, maybe that you are.
Actually, I can give you an example. X, Y are days of the week. ABC are months. You could easily have. No, that won't be that. No, that's not an example. In fact, I mean, that's a pretty obscure thing that's happening here. I mean, inner isn't your average least obscure function either. I mean, I tend to think it would be nice to have a name where the default operation is this, but where there's sort of an escape valve, maybe just a third argument or something, which can give the explicit functions to use.
Yeah, we have, for example, distribute, in which, because we put the f and g functions at the end, you are not forced to write them.
Right.
Like you are in map or in map thread, etc.
Right. Okay. Well, okay. So the main issue here, I think that makes more sense to put them at the end. But the main question then is, okay, I mean, this is sort of an array labeling exercise.
Yes.
I mean, that's not the right name, but didn't we have a name like array key or something?
We have suggested many names for this. We had names related to relabeling, which I didn't like.
No, that doesn't make a lot of sense. Yeah. And I mean, honestly, label isn't the right concept here anyway. Well, it sort of is, because the main place is going to be associations or possibly rules.
But then I think a key would be nicer than label.
Okay. Key distribute just is absolutely incomprehensible for what it's doing. I mean, it's really put keys into an array. Let's think.
I was trying to find connections to other functions, and there in that notebook, there's a connection to distribute and another one to MapIndex.
Is that the MapIndex? That's really obscure.
So, well, the difference with MapIndex is that MapIndex is going to insert the full part specification, while here we are inserting the key at that level, and not the sequence of or the list of keys that leads to that point.
Right. I see. MapIndex. So your point is that it's inserting that MapIndex just looks at. Yeah, I mean, that's another case that you could do here, except that what you're doing here, there's a case where you're telling it what indices to use. Whereas here you're just taking the naturally occurring indices, so to speak, and putting them into the function that you're applying. Okay, so boy, there are so many bad names that immediately come to mind about index array and so on, which immediately means completely the wrong thing. Okay, so how do we think about this? This is taking it's an array, but we want to put, I mean, it's sort of, I mean, there are ugly composite names like, I mean, that's in the category of totally incomprehensible, but it has at least a soup of words that give you some chance. What are some other array type names that we have? I mean, we've got things like array reshape and so on, which feels somewhat similar to this.
Well, but this is more than reshaping it, it's changing the type, because we are returning an association. So a possible name could be also array association. But I'm worried that these are two really, really big players.
Yeah, I agree. I think that's obscure. I think that's a name we had at one point for this.
Yeah.
Right. So this is not a totally, unrelated function, because this is telling you, well, this isn't restructuring the array here.
Right, the dimensions are kept.
In what sense is it related to distribute?
Can you go a bit up in the notebook on the right? Yes, so here, yes, so here you see this last example in which I'm replacing f and g by times and plus, and suddenly we have a linear combination. You see the one you are now pointing with your cursor. And so that's an operation that looks very much like distributing.
If, wait a minute, if f and g are times and plus.
Right, because those are the defaults for distribute.
No, I understand. Right, so you're claiming that this operation here is like times and plus, what?
Yes, f and g are in many places functions with defaults times and plus respectively. And yes, so we are always having f when we have times as the main function. Like,
okay, but what does it do in terms of algebraically here?
Yes, it's multiplying the elements of the first array of the first object with the second object.
Yeah,
and then adding the whole thing. So
it's multiplying at level 1 by x ABC and multiplying at level 2 by xy.
Exactly.
And adding everything.
Yes.
But that's not what distribute does, right? Distribute takes, what does distribute do? What does distribute do at multiple levels here? So this is F, G, A, B.
No, distribute doesn't have a form of multiple levels. In a sense, in the same way that we have thread and map thread, there is distribute and this other thing that could have been separated into the functions and the arrays, and then it will look closer to this function I'm suggesting here. So distribute is very close to thread in the sense that it requires an expression which already contains the heads inside. And then map thread was created separately, but we don't have a map distribute.
What would map distribute do?
It will be a bit what we are doing here.
Except it isn't, because in that case, map is actually putting, the function onto each of these, whereas here we're doing an association play, so to speak, instead of the function, right? I mean, this could be, we could imagine our mystery thing here. Let's just take a simple case of it, right? If we said list FG, list XY, could turn that into f of x, g of y, right? That will be the mappy thing to do, right? As opposed to what we're actually doing here, which is to make those association elements, right? Whoops. Makes sense? Right, so I mean, this would be, I don't even know how you do that. And that would, I see, the relationship between this and what you're saying is, it's like a distribute relationship, because what you're doing is you're saying that really is a rule, F goes to X, and then the whole thing is wrapped in an association rather than a list.
Yes, something like that. I cannot claim I fully understand the relation. I will try to suggest, well, to construct this map distribution.
So, I mean, what this is saying is that this thing here is being inserted, those arguments are being inserted as keys in an association, yes, as opposed to those arguments being inserted as heads, like in this case here.
Yeah. I guess that in distribute, we have the is the coefficients separated from the x, y, and z in the first example in the distribute page. And it feels similar to, I have the keys separated from the array. And now I distribute them and I have them all.
No, I agree. I agree. But look at the case that I'm talking about here. In this case, the functions are being used as heads. In this case, they're being used as essentially labels.
Yes, but we have key in the name, so I think it's...
Well, no, I understand that, if we have key in the name.
Right, exactly, yeah.
I mean, you know, the only name here that is even vaguely making it for me is array key distribute. Well, one thing is clear. We can certainly implement this function. Well, you know, the only question is, if it is array key distribute, then what we've got is essentially the labels, the array, and then potentially we have F and G.
Yes. What I've added as well, you can try is a level spec, so that you specify how deep you want to go in converting. So let's see if I have an example. If you go back to...
I see. So, I mean, for example, if labels had lists, if some of the labels were lists, you have to specify depth there. Right? I mean, in other words, if F and G were lists, they could represent another level down in the actual sort of burrowing through the array, or they could merely be that you want the label of something at level 2 to be XYZ or something.
Yes, you have an example a bit above in the notebook.
Okay.
If you scroll a bit, yeah. Yes, that data set there.
Yep.
You see, it's still keeping the lists at level 3. It just inserted, and that's why there's a 2 in as third argument.
What happens? What about lists in the keys argument? Oh, I see. The leafs of the keys argument. I see. They've got to correspond. So that means that you go down to level 2 in both the keys and the array.
Exactly. Yeah. And you keep the values. If the values are still lists
at that level, you keep the lists.
Exactly.
So are you proposing that occur before the F and G? What do we have a precedent for that? We do, I think. So for something, what do we have that? What's that for? Something has a level spec precedent, I think, here.
Could be. I think it's more important than the FG.
Outer is a horrifying varargs function.
Yes. Perhaps level itself.
Boy, these are old functions. And it was in version 1. Sorry, which one? Level?
Yes, level is able to go down.
Yeah, okay. So that does something a little bit like this. It takes a level spec and then it has a function that can be applied.
Exactly.
Ooh, a 5-argument function, eh?
Perhaps the first 3 are enough, and then we see whether the need appears for the others.
By the way, somebody is asking, and I think this calls for a small demo of whether there is a chat functionality. Yes, in version 11.3 there is chat, and we should be using it for these meetings. And I'm even going to say, I could add some of you to this. Next time we should use this. A chat. We've been saying we're going to do this for these live stream things to provide people the possibility of joining our chat session, which would then allow all sorts of Wolfram language expressions to be just sent back and forth. Okay, but back to this for a moment, and then we need to wrap up, unfortunately. Look, I think array key distribute, it's a horrifying name, but I think it's the least bad we've had.
Okay.
It's kind of a horrifying thing. So I mean, the official version of this would be F is what? Rule?
Rule. Yes.
And
But,
G is association.
yes. We should put them GF, like distribute.
So it will be association followed by rule?
Yes. To follow distribute itself.
Okay.
And those are the defaults. You have to write them.
No, I understand that. But so if I wanted to do the other case, I would do list and construct. That would give me the map case.
For example.
Okay. Oh, gosh, this is so obscure because the fact is people are going to use this to label rows and columns. That's what it's in practice going to get used for. An array key distributor is one of the more obscure things you could call essentially something which is conceptually labeling rows and columns. Okay, so what it's doing is, you know, at some level it's turning lists into associations, which is how we ended up with array association, which again, as you say, is I think too that's too big for this functionality, presumably.
Yeah,
Unless it isn't. How common do we think this is going to be? What's the inverse of this operation?
It's some sort of multi-level values.
Yeah, which we don't have, so far as I know. Values right now, it doesn't even have a second argument, I suspect. Interesting. So it's listable. I mean, the other version of this is sort of like, I mean, this is really array to association. But now how do we, what is the other version? There's an association thread, which is trying to do something like this as well, right?
Yes, at one level. That's another thing we discussed, the possibility of generalizing this function to do what we are suggesting, but we thought that the multi-level nature didn't fit very well.
Okay, what about the following possibility? I mean, what we've got here, I see. So we've got a two-argument form of this that has the keys and values separated like that. That's unfortunate.
Well, of course, association thread might want to use keys which are lists themselves.
Exactly. So we can't do that without saying, I mean, the default for association thread can't be to do this. We would have to give association thread a second or third argument.
Yes, specifying at which level we have the keys, or require that users insert key so that we are sure these are keys.
Why is that going to work to insert a key explicitly? I mean, in other words, I think you want the other way around, right? Because you've got to be able to take, look, if we take something which is like, let's take our example here. Okay, you got that thing, and that would be an association thread. So let's see what it would look like. It's association thread of that, the thing itself. Okay, so there we go. You know, association thread is not completely crazy for this. It's really not completely crazy. Because as you point out, we're going to have a level spec anyway in this array key distribute thing.
Yes, but thread and is a different operation. It takes itself a level spec and it uses it differently from what we want.
What does it do?
It goes down in both arrays. In this.
So does this.
Well, but the first argument of what we want, of what we are suggesting, is not really an array into which you go deeper. The depth is represented in the argument number.
I see what you're saying. So these X, Y could be lists, but the fact is the top level. Oh, now I'm completely confused. I think you're wrong that there needs to be a whole level spec, right? Because I mean, the case where this has lists here would look like this.
Yes, but that's fine. What I'm saying is that those X1, Y1 are the keys of the second level. Not because they are at level 2 in that array. It's because they are in the second position of that list.
I agree. But what I'm saying is, why do we need a level specification? Because other than, I mean, then just if you don't want the level, if you don't want all the levels, do a take on this list.
Yes, but what I'm saying is that for what we want, we need a matrix in the first argument. And association thread wants only a list. So we have this conflict.
Wait. What we need, I understand. What we need is one more level of encrusting in association thread.
Yes.
Well, okay. I see. Otherwise, association thread can't know the difference between a list of keys that are supposed to be lists and the structuring thing.
Exactly.
So the reason we talked about array relabel is by analogy with array reshape, although the argument order is opposite. Someone is asking, is it a bad, SWSH is asking, is it bad to have a couple of built-in synonyms for the same function? Yes, we've never done that. We've never had to do that. And honestly, two utterly obscure synonyms won't help us. Let me see. Okay. But by the way, I mean, this level of thinking, I think we had gotten part of the way there before. We kind of need to finish this right now. I'm late for something else, but okay. So I understand. Okay. So right now we have that first argument. So what are some other examples where we have key functions that do something with keys like that?
I have the impression that the general theme here is that the association functions are very one-dimensional. Well, here is one of the first cases in which we want to handle associations at a multi-level. That's why we are finding new ideas.
Yes. Well, but that's why we have, okay, that's why the array word is coming in there.
Mm-hmm.
Is distribute the right concept? So we've got an array, we've got a key, but what are we really doing with it?
It's one connection. As I said, threading, distributing, and map indexing are things that seem similar to me.
What about array distribute? Or is that completely crazy?
Well, given that the first argument are keys,
Well, they're only keys if it can turn into an association. I mean, it's very bad if if everything is key-like, and then we find out that the escape valve case with different F's and G's is common.
I think perhaps we need two functions, one which is very key-oriented, and the general case.
Let's just talk for a second about array distribute.
Mm-hmm.
And what would it say? It would say distributes the keys. What would it say? It would say creates nested, that's kind of weird, creates a nested association by distributing the sequences of keys, blah, 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 over the array, blah, 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 over successive levels in the array, blah, blah, blah. I think that description is okay. Creates a nested association. What else would array distribute mean? What is there a meaningful name? I mean, association distribute seems kind of crazy. Is that crazy?
Well, there is no obligation of having an association in input. So array seems better.
Why don't we go ahead and implement this under the name array distribute, which we may yet regret, and then discuss it again? Or is it implemented already?
I have some small prototype. You can look at the code there in the notebook.
I don't want to.
It's quite small.
Does the code have any weirdness in it? I mean, is the code telling us that something is crazy in some way?
No. It's a combination of nest and map thread. That's the origin of calling this nest thread originally.
Nest thread is so obscure. I mean,
I agree. It is. I was just letting the code suggest them.
Yes, fine. Array distribute. See, people are going to think about this as labeling. Array distribute. I could imagine this not being total. What do you think about this? Do you think this is too general?
No, it's fine. I may miss key a bit because I think key is the fundamental. I mean, it's even in what you wrote, sequences of keys. But
yes. Yeah, but remember, then the other case is, array distribute. Okay, so do we need the level? I claim we don't need the level spec. I don't think we need the level spec.
Yeah.
And then we need the outer and the inner functions, right?
Right.
And this would be by I see. Creates a nested. This is basically a nested outer F by distributing sequences of distributing. Oh my gosh. The function, it's basically by distributing inner F of hash 1.
Well, I have two comments for the documentation. One is that we can still have what you had before, which was clear, and then say in different lines.
Oh yeah, sure. I'm not worried about
Replace.
that. Yeah, I understand. Replaces association by whatever.
Exactly.
I was trying to see whether there was a better. I wonder what we do for distribute. Maybe for distribute we just do that, because maybe anything else is too obscure.
We can also explain it like map thread does, which is with the actual formula.
Yeah, right. All right, I think I have to go to the next thing here. Let's implement it as array distribute, and let's see if we can write documentation under that name.
Okay.
Great. Okay. Thanks to everybody on the live stream, and talk to you all soon.
Okay. Bye.
See you. Bye.
Well,
Bye.